Everybody, good afternoon. Second session of the forum. I hope everyone is having a wonderful time so far. My name is Laura Cattell-Knoll, and I work at the Alliance for the Chesapeake Bay. So I will be the moderator of today's session. So in just a moment, I'm going to be handing out evaluation forms. At the end, I will be collecting those. And if you fill one out and I collect at the end, then you get a little raffle card, two raffle tickets to take with you to the poster session, which is tomorrow night. You'll get 2 raffle tickets for me, and you'll put one in the raffle bucket and then keep the other one so that if they pull yours, you know if you have the right number. So I am really excited to be introducing our speaker today. Oh, I'll say for those folks participating virtually, you are also welcome to send me a chat if you have any technical difficulties. I'm here to help with that as well. So I'm really excited today that this session is on biochar and climate resilient landscapes. We have an amazing speaker here today, Lilly, who's a natural resource management professional with an MS in marine and environmental sciences, over 15 years of experience in watershed planning, implementation, project management, water quality monitoring, and writing. She's a leader and an independent thinker with a passion for environmental issues and a demonstrated commitment to improving water resources through grassroots efforts. If you're familiar with Lori's work, you know that all to be very true. So Lori initiated, developed, and manages a debris management program in flood-prone Ellicott City, Maryland, and provides regional and national leadership for environmental management and innovations such as for biochar and illicit discharges. Lori founded Howard EcoWorks in 2016 to be a regional force for social and environmental change. EcoWorks engages and educates the community about environmental sustainability and restoration while creating pathways to green jobs through workforce development programs. So please join me in welcoming Lori.
Thank you. It's good to be here with you all today. So we'll go ahead and get started.
Yeah, oh, you gotta put it to the computer, I think. It's okay, I can click if that's easier.
Okay. I'm sorry, are you able to move that to the side? All right. So Howard EcoWorks is a nonprofit organization. We're based out of Columbia, Maryland in Howard County. Our mission is to empower communities and diverse workforces to respect and restore our natural systems for future generations. We work at the nexus of workforce development and environmental restoration by administering multiple green jobs programs. And we are very community centric. We work very closely with community and our community partners to help build resilient communities. Next slide. So we were formed in 2016. I'm the founder. We are on a daily basis designing, building, and maintaining different types of environmental projects, not just in Howard County, but also around Howard County as we continue to grow. Our environmental goals are largely focused on the conservation and restoration of plants and soil. Next slide. I'm going to tell you a little bit about our company, Howard EcoWorks, and the programs that we have going on. The READY program is Restoring the Environment and Developing Youth, is a summer green career exploration program for 16 to 25-year-olds. Young adults are trained in and become knowledgeable in issues related to the Chesapeake Bay and stormwater. They receive Chesapeake Bay Landscape Professional Associate certificates. They receive leadership training, team building experience, and are out in the community building and maintaining projects. Next slide. We have a program called Uplift, which is more of our true workforce development program, where we are working to put people into a training program and help them in their next steps into environmental careers. This is a 6 to 7 month program. We run in 2 cohorts per year right now. We have a partnership with the Maryland Department of Labor for our Uplift program currently. This means that it's an employer-driven training program, and the employers are the ones that are guiding how we're implementing our training program in order to most effectively put people into careers in the environmental sector. In this program, we're mostly targeting open space management, stormwater management, environmental restoration, and tree care as the primary industries where we're trying to feed into the workforce. Next slide. We also have a program at our local detention center called Seeds of Change. We operate a native plant nursery at the jail, at our local jail. It's operated just outside of the fence. The inmates volunteer their time and working with us a couple times per week on various tasks related to maintenance of the nursery, such as potting up of plants and watering, weeding, that kind of thing. In addition to just simply being able to get outside of that institutional environment and experience nature, they get some exercise, they get sunlight. But for those that are really interested, we offer a paid internship to them upon release to help with supporting reentry back into society. And the Seeds of Change nursery is kind of a business in and of itself within Howard EcoWorks. We're trying to make it a financially sustainable operation through the sale of retail plants. These are all, again, they're all native plants, and we're actually open for business 5 days a week in the mornings in Jessup. Next slide. We are very interested in equity issues and supporting those that may not be able to come to the table on environmental issues the way all of us do. We are working in partnership with the Howard County Public School System and working with students with disabilities on our seed conservation program. Right now, the students are making these seed packets and these seed bombs for us. Seed bombs are kind of like a little ball of clay and compost and native plant seeds that you can like toss into vacant lots or put into a little pot. But the students are this is a part of their workforce development programming within the school system. It's very incredible. Next slide. I wanted to just mention a little bit about the services that we offer at Howard EcoWorks. Our primary client is Howard County government. They are less than 50% of our budget, but they're still one of our major clients. We provide direct services to them that I'll talk about in just a second. We also have other great grant-based services in the Baltimore region, mostly around planting native trees and native conservation landscapes in urban and underserved areas within the region. And then we have a growing fee-for-service line of business that's supporting our organization, and I'll tell you about that in just a second. For Howard County government, we are providing service to the county in terms of flood mitigation in Ellicott City. It's our county executive's kind of branded plan for Ellicott City flood mitigation called Safe and Sound. Our teams are in charge of responding after triggering wind and rain events. We send our crews out into the field to do inspections at 56 different points around the county to monitor for debris. And then we're in charge with cleaning up that debris or assigning it to Howard County government for them to remove. We also maintain all of, or not all, but 17 to 20 of Howard County's stream restoration projects, their capital projects, which are their primary investment into meeting their stormwater permit requirements for the state. We are the caretakers of those projects. And then we have a program called Tree Hoka where we are planting trees within the Green Infrastructure Network in Howard County. Again, we have other grant-based services. We right now have multiple grants from National Fish and Wildlife Foundation and the Chesapeake Bay Trust to plant a couple thousand trees and 12,500 square feet of native conservation gardens and pollinator gardens in urban and underserved areas. We also hope to recruit from these same areas for our workforce program so that we can create kind of a cycle, an economic development opportunity within those areas around environmental restoration. Next slide. And then again, we have multiple, this has become really important to us, especially after the pandemic, to support our nonprofit organization. We launched and built up a number of fee-for-service lines that are now about a third of our total budget. We have consultation services with our landscape designer or arborist that are on site with homeowners. We do design build projects. We do seasonal maintenance, mostly on our own projects, but we can also maintain bioretentions or other types of facilities that other people have built. Rent an eco crew services is literally what it sounds like. A homeowner can rent a couple crew members to do client driven work on their property. That's been a really growing area of kind of organically growing business for us. And then we do a lot of woodland management and forest management. Excellent. So to the topic at hand around climate resilient landscapes, these are probably might be terms that are familiar to you, but I just wanted to review them quickly. In terms of resilience, we're talking about the ability to persist and adapt over time with a changing climate, focusing specifically on biodiversity and ecological functions. With biodiversity, we're talking about all the biodiversity on Earth and recognizing that all of that is not even known to us at this time. There's many species that have yet to even be identified. And then in terms of ecological functions or ecosystem services, you may have been called, this is kind of a human-centric term that refers to the benefits that we receive as humans from wildlife and from nature and ecosystems in general. And they're kind of clumped into these different types of categories called provisioning, which is food and water, regulating services, which refer to things like pollination and decomposition and carbon sequestration, supporting services, which would be photosynthesis and nutrient cycling, and there was one other one, cultural, which refers to recreation and building knowledge. So we're trying to pull all these things together in the work that we're doing. When we're talking about resilient landscapes, we're talking about working with nature and not against it, using more nature-based solutions rather than infrastructure-based solutions in order to cope with these changing conditions that we have. We want to understand and factor in risk into our planning, and in particular, the risks that we're talking about are heat and fire, flooding, the loss of biodiversity, and drought. We want to use intentional processes of using landscapes to mitigate climate change and promote resilience and biodiversity loss. And for us at Howard EcoWorks, that focus is really around plants and soil. And we also want to think about, real quick, adaptive management in this whole framework. For example, we have a lot of old and outdated stormwater management facilities that were built prior to our new standards. A lot of these can be retrofit to be more functional, for example, by incorporating biochar into them, by incorporating large amounts of native plants to increase biodiversity. So adaptive management in this context, referring to taking some of what we used to know and how do we retrofit that in order to make it better for what we know is happening now and what is coming down the line. Okay, so now we're going to move into biochar and climate resiliency, but next slide. Real quick, I want to talk a little bit about the role of fire in our systems, and our current urban and suburban systems, particularly our forested systems, ecosystems which are very unhealthy. As I'm sure a lot of you are aware, we have a lot of invasive species like vines, shrubs, invasive pests that are really deteriorating the quality of our forests. And the effect of habitat loss and fragmentation in our urban systems is being exacerbated by the lack of one of the important ecological processes that have controlled those impacts, which is fire. Next slide. Fire, back in the day, was a really important component in regulating our natural ecosystems. Lightning and Native American ignited fires were frequently and extensively used over our landscape and helped to develop and shape the character of our land. Fires have different frequency and intensities and severities that help to create these different environmental gradients and the different habitats that we see in the landscape. Again, it was a major ecological process that is currently lacking. And so therefore, because it has been suppressed, we're seeing a lot more degradation and an exacerbation of the problems that we have with invasive species and pests and deer because we're missing this in our systems. Next slide. So this is kind of where we're starting to bring in biochar into the ecological context of what we're seeing. Biochar is a zero waste solution. It's a charcoal. It's made by a process called pyrolysis, whereby an organic matter is burned at a very high temperature in a low to no oxygen environment. And it's also a very ancient practice. It's had a new resurgence, but it's been around for a really long time, for more than 2,000 years. It used to be used in agriculture in the Amazon in order to promote plant productivity. Next slide. There are different types of what are called feedstocks that can be used to make biochar. Any type of organic waste can be made into biochar, but they make biochars that are of different properties. We're not talking about taking healthy forests and cutting down healthy forests to making biochar. We're exclusively talking about using waste materials that would otherwise go to the landfill or other types of waste that are in abundance and converting them to something that is very beneficial. We also want to be careful not to use feedstocks that might contain high toxins or heavy metals or other things that we don't want to put into our landscapes. I like this graphic because it kind of shows how a process of how you make biochar. Again, a really high temperature, low oxygen. When your organic waste starts to turn into a charcoal, that's when the process is stopped, and you basically halt the combustion process and keep the organic matter from turning it into ash. Next slide. So you can make biochar in different scales and in a lot of different ways. You can make it in industrial facilities like a gasifier. Pyrolysis and gasification are terms that you hear when you're talking about processing and making biochar. The only difference between the two is that there's a little bit more oxygen used in gasification than in pyrolysis, but otherwise you end up with a product called biochar or some kind of energy like oil or gas. I also like this slide to show the comparison of the carbon cycle with what we think of as the biochar cycle. So if we have lots of organic matter, any type of organic material, if we allow that material to decompose, it's going to go back into the atmosphere in the form of carbon dioxide. But if we have all of that biomass and we take that and we intercept it with a process called pyrolysis, then we convert it to an inactivated carbon biochar and then your oil and gas, and you basically have reduced the amount of carbon dioxide that you put into the atmosphere significantly. And hopefully you can reuse that waste in the system to continue fueling your biochar production process. The Nature Conservancy in this graphic, they have listed biochar here circled in red as one of the climate mitigation strategies. It's lined up here along with reforestation, urban reforestation, fire management, cropping. It has a really good potential for mitigating climate, even according to the Nature Conservancy. Next slide. Has a tremendous number of benefits. We can use it as a soil amendment. It increases the organic matter of the soil. We're taking waste products and converting them to something that's a resource that we can benefit from. There's a lot of research into its potential for reducing stormwater runoff and removing pollutants. It's sequestering carbon in the ground, and it's a very cost-effective practice. In particular, there's been research done using biochar as a soil amendment, and stormwater applications is a very cost-effective strategy compared to other things like even tree planting. It's shown to be very cost-effective because you don't need, for example, large amounts of land, and there's not a lot of structures involved. You can simply amend the soil with biochar, and then you have a way to reduce stormwater runoff and remove the pollutants from the landscape without a lot of infrastructure and while keeping the land use the same. Next slide. I also like this slide from the University of Delaware because it gives a good visual for how biochar works in the soil. And one of the main properties of biochar that makes it effective is all of the pores that are in each particle of biochar. So if you have your regular soil, you have a volume between the soil particles, which is what's holding the water. Biochar, you have the particles, but then you also have all of those little pores that have been made because of that pyrolysis process within the biochar, which creates extra capacity to hold water. So when you put the soil with the biochar together, you've significantly increased the ability of the soil and the biochar to hold water and retain water. Okay, next slide. I've been making biochar on my own, not in one of those big gasifiers, but in this kind of kiln system. This is a kiln called a ring of fire kiln. It's this one I got shipped out from Oregon by a woman named Kelpie Wilson, who does a lot of biochar related work in the Pacific Northwest, in forested systems and for managing like the slash after a deforestation operation, for example. This works in a similar way in terms of creating a very hot fire with low oxygen. Unlike what you're taught if you were in Boy Scouts, where you make the fire on the bottom, with this kind of system, you actually make the fire on the top, which helps to eliminate or limit the amount of oxygen that's interacting with the fire. It's also closed off on the bottom, so no air is coming through here. And it's actually, when the smoke and such is released, it's kind of due because of this kind of conveyance here, the fire and the smoke is sucked back down into the fire, so you create less smoke than you would with a traditional fire. So you build the fire on the top, you kind of cook it down, your coals are forming on the bottom. When you get red hot coals, you put the fire out and then you have your biochar. Next slide. When I'm managing wood on my little 1 acre postage stamp in Howard County, we manage a lot of invasive species and, you know, just kind of dead material that's lying around. We accumulate it in different piles around our yard, leave that for the wildlife so that they have places to nest in over the winter. After it's all dried out, we burn it up into biochar and I use it in different places around my yard. Next slide. So there are different types of applications for biochar. Again, you can use it as a garden soil amendment. It's really good for increasing plant productivity and improving soil health, particularly of acidic soils, because biochar is a little bit on the basic side, so it can help ameliorate acidic soils. It supports and improves the composting process. It improves the effectiveness of stormwater management practices, which we'll talk about again in a minute. You have the ability to manage organic waste. And then there's also a lot of talk and discussion around carbon credits. I'm not super knowledgeable about that, but I know it's a growing area of concern. So I'm going to talk about two of our biochar projects that we've done at Howard EcoWorks. And actually, while I'm doing that, I'm going to pass around these little samples of biochar that I have. I've got like what I call a commercial biochar product. This is, you could buy this on Amazon in a bag, for example. This biochar is my kiln produced biochar, and this one is kiln produced biochar mixed with compost. So I'll pass those around while I'm talking. And you can feel free to open up the lids if you like. So I first got interested in biochar actually from my friend Paul, who's sitting right here. He's done a lot of work with biochar. But with regards to Ellicott City and the flooding that we've seen there, prior to the 2018 flood, I had been working on a campaign through Howard EcoWorks to help engage private landowners in actions that would mitigate stormwater runoff from their properties. Howard County government was largely focused on mitigating runoff from the large impervious surfaces in the Tiber watershed, which drains to Old Ellicott City. I was interested in a grassroots campaign to engage landowners in the management of runoff from their turf grass, which actually has a lot of runoff. In this graphic, you can see it's a little bit blurry, but this is the root system of a turf grass, and this is the root systems of our native plants, significantly deeper and have much more ability to soak up water with native plants than from the grass cover. So we wanted to engage, and if you see my shirt, kill your lawn. So this is cool. Okay, we really discourage lawns at Howard EcoWorks. We want to see all of this converted to native plant landscapes. This graphic on the right is the Tiber watershed. with Ellicott City down here at the bottom, and all of this is turf cover. We have a lot of turf cover in that little tiny watershed that's creating a lot of runoff. But not everybody wants to make a rain garden or a native pollinator garden in their yard, which is kind of one of the places where biochar comes into play, because you can increase the ability of the soil to infiltrate stormwater without changing the grass. You can still play frisbee, play with your dog, and yet you still have an ability to soak up the water better. So that was kind of what we were interested in doing, and we began a research project with the University of Delaware to kind of see what we could do with that. Next slide. We chose 2 test sites, St. Peter's site and then another site called Slack Funeral Home. And we did 2 plots of control plot and a biochar amended plot at each site. They were each 2 by 2 by 2, 2 feet in square and 2 feet deep. We removed the sod, excavated the soil, mixed it with biochar in the case of the biochar amended soil, and put the other soil back. Next slide. In this case, we added and mixed the biochar at 4% by mass in the site that was amended. Next slide. And one of the measures that the University of Delaware looked at was the saturated hydraulic conductivity, which is the ease with which the water, when it's saturated with water, will still be able to transmit and move water within it. And we found that the biochar amendment increased the saturated hydraulic conductivity by a factor of 2 to 10. Next slide. The University of Delaware took this information, and with some modeling, they determined the infiltration rates of the control in the biochar amended soil. And we can see that the biochar amended soil increased the infiltration by 34 to over 95% compared to 20 to 40% in the control plots. So it was a good experiment. It mirrored what the University of Delaware found in their own research studies in road rights of way in Delaware, where they were seeing similar results. Next slide. In our next project, we're taking a little bit of a different thought process with biochar and its impact in our company and an impact in our work. We wanted to look at the carbon accounting of our company, Howard EcoWorks, how much offsets we received for carbon with all of our implementation work, which would be tree planting, rain gardens, conservation landscapes, and managing forests. We wanted to look more at the kiln produced biochars, and I wondered how these performed compared to the commercial biochars. So we looked at some of those in the lab, and then we also did some field trials with the kiln produced biochars compared to the commercial biochar. Next slide. In terms of our carbon footprint, we determined that our company had a footprint of 54.5 tons of carbon annually. Most of this is from employee commutes coming to and from our office, and also from our trucks moving around and doing all of our environmental restoration activity. For comparison, a regular homeowner might have a footprint of around 16 tons per year. Next slide. So my wonderful interns did the hard work of determining the carbon offsets that we would receive from all of the environmental restoration activity that we're doing. And that we determined that with our restoration work, our carbon footprint was reduced by about 34%. Next slide. We had a little bit of trouble determining what would be the kind of carbon impact of managing forests. So in this context, I'm talking about like these unhealthy forests that have lots of vines that are decreasing the lifespan of trees because they're so heavy and pulling the trees down. There's not a lot of information available or research available around this particular topic. There's even some conflicting evidence that the invasive species are actually holding more carbon because they create so much biomass. So there wasn't a definitive answer that we could come up with in terms of this part of our work. Next slide. We did we wanted to know if we added biochar to all of our environmental restoration projects, how much further would our carbon footprint be reduced? And it would be reduced by another 33%, is what we determined if we were able to add biochar to all of our projects. So a total reduction of 66%. Next slide. In terms of the kiln-produced biochars, kind of the thinking around this is for those of you that are familiar with stormwater, we talk about keeping stormwater on site. You want to manage water, you want to sink it into the ground right where it lands. This is kind of thinking in the same way with carbon. How can you keep your carbon on site and in the ground and keep it from going into the atmosphere? And one of the ways is with these kiln-based systems that are very hyper-local, we can take, organic waste and make it into an inactivated carbon that is not going to go anywhere. So there's also a business model case that we were looking to build around how we could do more woodland management and incorporate this biochar component in order for Howard EcoWorks to be able to provide additional services to communities. We wanted to know how effective are these kiln-produced biochars compared to something that you would buy at the store. How are they for sequestering carbon and for treating stormwater runoff? Next slide. Yeah.
Did you say you had bought one, a biochar? A kiln. You bought a kiln and built it. What was the location or the manufacturer?
Wilson Associates. Kelpie Wilson is her name, and she's in Oregon.
She also can provide the blueprints for them as well, and we had one made in Ellicott City by like a welder, an artist as well. So anyway, that's an option.
So these are the feedstocks that we were looking at with this project. We chose 3 invasive species: Chinese privet, autumn olive, and paulownia. And then we used 1 native species in our experiment, ash, because we have so much dying and dead ash from the emerald ash borer. There's huge amounts of biomass available, so we wanted to look at that one as well. Next slide. This is the process of making the biochars with the interns. Unfortunately, they were doing this in July. That's why we haven't, I was there with them, so it's all good. So we collected the feedstocks. We chose material that was already dead. And then we made each of our batches of biochar basically in the ring of fire kiln. Next slide. And then, as I mentioned, we were also doing some field trials. This is where the University of Delaware also came in to help us with this monitoring. We ended up using the ash biochar and the privet biochar compared to the Oregon Rogue, also just going to call that the Amazon biochar, the stuff you can buy at the store. And then we compared that to a tilled and unamended plot. We installed these plots at Howard Community College in July of 22. And the grad students had been coming out to monitor those plots. Next slide. This is a lot of little numbers. This is a little bit of the lab analysis from our work, just a selection. So we have our different biochars here: privet ash, autumn olive, paulownia, Oregon Rogue, or the Amazon biochar. These are our standards. The standards that are available to us are from the International Biochar Institute, and also the European biochar standards are the standards that we have available. One of the things that we look at is the carbon content of the biochars. IBI classifies them as greater than 60% as a good quality biochar of carbon. So our privet biochar and our ash biochar were class 1 biochars, and the autumn olive and the paulownia had a carbon content that was less and an ash content that was more. I'm showing just a sampling of some of that heavy metals that they looked at. These were all unremarkable, as they say in the medical world. They were all were mostly below standards, all except one. The paulownia biochar for copper was a little bit high compared to the European biochar standard. And then the poor, they also looked at some of the poor areas because it's an important factor. Again, because that's what's holding the water and holding on to the pollutants. Some of that information is a little bit conflicting to me. For example, the Polonia biochar has the highest average pore diameter, but they're the smallest pore area. I mean, I'm not an expert, so I'm not really sure what that meant, but, question?
Yeah, I mean, not to get too wonky, but it's interesting that the Europeans have a standard here. It's actually not really surprising that they would be ahead of us on this. Like, can you say something like, is it because they have carbon market, like their financial markets are more evolved than ours, or is there some other explanation for it?
I'm gonna turn it over to my friend Chuck for that question. He's sitting right next to you because I think that he knows.
Yeah, you're correct. The market is much more demand. They're in whole urbanized areas, very little land to apply materials on. So their market space legally, they have much wider uses for it. So they'll designate biochar for animal feed, they'll designate biosolids for various uses, construction products. So they have a much deeper, and I will say that, you know, an EBC, which is European biochar certification analysis, is way more intensive than what we currently do in the US. So, but yeah, the market's driven. The EU is a big driver of a lot of it as well. So.
Okay, thank you. Thanks, Chuck.
You have a question virtually?
Okay.
How long do the positive effects of biochar last? I imagine it decomposes.
It lasts a very long time.
Hundreds to thousands of
They
years.
say
of
hundreds to
permanence.
thousands of years. But none of us have been around that long yet to be able to. But I mean, we know it from the Amazon that
Right,
the
that's what I
material
was
has
gonna say.
stayed in the ground for 2,500 years. So
Right.
has a very high longevity.
But it's
Longer
really
than-
dependent on feedstocks. I think some are shown to be a little bit less recalcitrant in terms of how long they're staying. Like the certain amount that you put in, some of it does have a tendency to decompose. There's still a lot more research that's happening around it.
There's a lot of research that's happening for sure.
Tons of it, like 30,000 journals.
Yeah.
But actually, that aspect is driven by temperature. So.
Yeah, there are a lot of variables. Like the type of feedstock and the temperature are the biggest variables that are going to affect the properties of the biochar that you end up with.
And another question virtually, the pore diameter will have units of length. Might we know what the units are? More pores of smaller diameter could add up to the same porosity as a smaller number of pores of larger average pore size.
Right.
We're getting technical here. Does anybody know what the units are? Do you know what the units
I
are?
don't off the top of my head, but I can get that information.
Meters squared per gram.
Meter squared per gram. Maybe we'll hold the rest of the questions for now. Okay. I think I'm almost done. So, all right, next slide. So this is where also the University of Delaware was helping us with research. They were looking at the bulk density and the surface area of the biochars that we produced. Bulk density being the dry weight of soil divided by the volume and correlated to how compacted the soil will be. And of course, we know that compaction results in the inability of plants to really thrive and increases stormwater runoff. So that's why we're looking at bulk density. The commercial biochars had lower bulk densities than our kiln-produced biochars, though they were all optimal for root growth. So to my mind, they were comparable. The commercial biochar product was lower. The commercial biochar also has higher surface areas that allows for more microbial activity and improved soil structure, but still all of the chars met the standards as set by the European biochar standard, which is higher than 150 meters squared. So positive to my mind, because they're on par. They're not quite as good, but they are comparable. Next slide. We're also looking at, this is in the field trials, we're looking at compaction of the soil versus depth, over time, and with the different types of biochars. In general, and this is a very kind of limited data set in terms of time. It was limited by the grant timeframe, so we didn't have a long enough time period in order to assess. Biochar really needs a longer time period than our grant timeframe, is what I'm saying, in order to see its effectiveness. But what we saw over the 2 visits, which is represented by the blue bars and the orange bars, is that the compaction decreases and then increases over time, which is kind of something that we already know. We also know this also, which is that tilling is just in and of itself is an effective way of decreasing compaction. But what we saw with this study is that the amendments were more effective at depth, down at 30 to 50 centimeters, in terms of reducing compaction. This is, we actually have another grant to continue monitoring these plots to see how the biochar continues to react with the soil over time. Next slide. Another thing that University of Delaware looked at was the volumetric water content. All of the chars were effective at increasing the water retention of the soil, but actually the most effective effect that we saw was with the privet-based biochar, and that's the gray bar and that graph over there. Next slide. So I did mention that just previously that we have another grant to continue some of this work. It is a little bit more broader in terms of ecosystem services and not just entirely focused on biochar, but for the biochar components, we're going to continue monitoring those field plots at Howard Community College. We're going to be doing some applications in a forested system where we're going to manage a bunch of invasive species. We're going to let that dry. We're going to make it into biochar, and then we're going to put it back into the forest floor and kind of document the pre and post conditions of some of the soil metrics. And then we are going to be developing some internal and external guidance. So internal for our company at Howard EcoWorks and how our crews can use biochar in our projects, and then external guidance for homeowners and people like that, because every time I start talking about this, the next question is, well, where can I get biochar? How much do I add? You know, all of these kinds of questions. So we're going to try to develop some guidance that we can provide to the public and homeowners. And then we are a part of a project. Chuck is a part of this project also and has a presentation tomorrow about a NIFWIF funded project scaling up biochar applications across the Chesapeake Bay. There's a lot of momentum around biochar applications, particularly as relates to stormwater management and its ability to increase the effectiveness and the efficiency of these projects. And we really want to see it used a lot more by municipalities in our stormwater management work. And this project is being led by the Center for Watershed Protection. So if you want to learn more about that, you can go to their talk tomorrow. Next slide. So I guess to cap it off, you know, my interest is in the ecological implications and the carbon sequestration potential. My company, Howard EcoWorks, has been driven a lot by stormwater management. Some of our major funding comes from the stormwater utility fees. So we've been very focused on doing stormwater management practices, but I'm very interested in the intersection of stormwater management with climate mitigation and how we can really push the needle on that type of work. And that's why I really am interested in biochar. Also because it has, you know, so many other benefits that I talked about during this presentation. And I also think that we can think about it in terms of being a mimic for prescribed burning. Prescribed burning is a way of managing ecosystems and habitats to help make them healthier. It's not acceptable in a lot of areas. It's not acceptable practice where we are in Howard County, for example. But I think that we can use this kind of very more controlled process to mimic that prescribed burning to help improve our ecosystems in general. Okay, next slide. That's all. So, I'm happy to take any questions. Let's start, I think, in the back there.
Lori, have you had to submit any like construction documentation to any local governments to get approval for your projects? And
No.
produce construction details?
No. And these are literally 2x2 plots. They're very small.
And I work in Pennsylvania and we had proposed a project using biochar on a farm, which would have made a whole lot of sense. It was denied by a group in Lancaster County that gets funding from a couple different buckets of money, but it was the Lancaster Clean Water Partners that denied funding it because they're not sure about biochar.
Oh, very interesting. That's very interesting.
All that.
Chuck?
On your carbon footprint analysis, what ratio did you use for your biochar? Because I would assume that your life cycle analysis of that is significantly high compared to commercial. So
We were looking at 20 years. What, maybe I didn't understand your question.
So biochar in itself is generally 2 to 3.7 times ton. For every ton, it's 2 to 3 times the CO2 equivalent.
Mhm.
So when you had your biochar analysis, did you calculate what your H to C ratio or your carbon foot? So is it, you could be 2.5 to almost 3 times because you're not trucking this stuff anywhere. You're like doing it right there.
Right.
So I don't know if you're underestimating your actual carbon value.
Possibly.
Okay.
Possibly. Yeah. I mean, I had the interns mostly leading that work, so that I don't recall whether they looked at that particular item.
Besides the University of Delaware's analysis,
Mhm.
did you have it sent out and tested to be able to get the IVI certificates on it?
We sent the lab samples we sent out to multiple different labs, University of Delaware and one lab in California, and another lab.
Control that.
Yeah.
Okay.
Yeah.
You should be able to calculate your ratio. on
Okay.
that.
Okay.
It's probably better.
Okay.
Hi, my name's Addie. I'm actually at the Community Ecology Institute, so.
Yeah.
Sweet fellow.
Howard County.
Yeah. I had a question about biochar as relates to invasive management and how the results kind of came back inconclusive. Were they inconclusive because of carbon footprint related reasons, that because invasives maybe have more biomass? It's
Yeah.
maybe not the best to try and manage that, or is it they were just ineffective at managing invasives?
What we were looking at didn't have to do with biochar in particular. We were looking at the carbon footprint of, like, if we manage invasive species on a particular forested plot, will we see an improvement in the carbon sequestration ability of the plants and the soil and the dead wood and all of that? That is the information that was inconclusive. There's not been a lot of study on the carbon balance of invasive species in healthy and unhealthy forests.
Thank you.
I had a question. You said that the carbon created a more basic, it's more basic. Are you just going to put the biochar on top of the surface in the forest? Have you created it, or you just may have changed the soil characteristics?
Right. So I think there are different applications or potential impacts from using biochar because it's basic. And it works best if it's mixed with compost and allowed to sit for a little while, and the compost activates the biochar and the microbial activity, and it all begins to work better. So for example, you were to put biochar straight into your vegetable garden, that would be a disaster because the biochar would compete with your plants for all of the nutrients. So you really want to mix it with compost and then use it in a garden application. With our application in the forested system, I have not determined yet how we're going to, like, exactly if we're going to mix it with any compost or anything before we apply it to the forest.
2 questions. For the commercial biochar, do you know what it's comprised, like what it originally was? And then the second one was kind of an add-on, like, what are you, do you want, like, what are you inoculating it with, like, besides compost, or is there anything else you want to kind of test out with biochar?
I think mycorrhizae fungi is a common inoculant for biochar. And I don't know, Chuck probably knows of other stuff that might be used as a good inoculant. In terms of like the commercial biochar products, to me, they seem, and Chuck might have something to add here as well, but to me, they seem like a little bit of the Wild West, because you don't, like, if you would want to see that the biochar that you're purchasing commercially meets the standards of the International Biochar Institute. But if you're like a regular homeowner, you might not know to even look for that. But then you don't necessarily know what is the feedstock of whatever is being burned to make the biochar that you're buying. They might change it up. I mean, there are the standards that exist, and the standards, I think there's still more work to do in terms of the standards. I don't know, do you have anything to add there?
Yeah, I mean, the standards are, as far as testing standards, they're being updated and modified on a couple fronts. As more information has become available, they're adding additional tests to it here shortly. As far as, in most cases, commercial biochars, they will get them tested under the IVI standards. The question is, has some of them tested it for, some of them will delve down into, is there PCBs, is there dioxins, is there, a lot of those areas, particularly those that are working in the water environment. But Lori's right, in some cases, they're small producers, and it's generally done locally. So it does boil down to the type of technology that's being used. And you do have to work with I would say, quality companies that are producing the carbon.
Yeah, and again, the feedstocks make different biochars with different properties, but you're not necessarily going to know whether your biochar that you bought from Amazon is going to be a hardwood-based feedstock or a pine-based feedstock or a manure-based feedstock necessarily, are you?
No, if you know who the producer is,
Okay.
And my first advice is don't buy from Lowe's, Home Depot, or Amazon, because you honestly don't know.
Yeah.
There's other some of the companies that are very clear as to what they're using and have certified, and they can provide you the actual tests, the lab tests. So, and Lori's right, every carbon is different, even down to the particle size might have an influence on your soils. So you have to understand what it is you're doing and using it for in that process.
Back there?
Hey, yeah, thanks. Really interesting presentation. I've got a ton of questions. I'll maybe try to do a sidebar with you afterwards, but I was really struck by the one chart. You had a slide where you put a chart of the regular CO2 cycle and the one that has the biochar part of it. And it seemed like the general takeaway from that chart was supposed to be that biochar would reduce the overall CO2 in the atmosphere. And I'm just really stuck on how that's possible when you're burning wood instead of letting it go through the natural cycle of.
You're inactivating the carbon. You're
Fixing it.
Otherwise it's going to all end up to be carbon dioxide unless you stop it from, you have to stop that process of the biomass degrading and decomposing and being put into the atmosphere.
So how is it that the biochar, when it goes into the soil, doesn't degrade like other soils?
That's the thing. It's just not activated, and it's a stable carbon source that will stay in the soil. And it's not going to go anywhere for a very long time.
Doesn't it get mixed with the biota and everything else in the soil, and doesn't that cause reactions that break it down?
No, it's not going to decompose in the same way. Compost, for example, will decompose in the soil over a couple of years and you will lose it back to the atmosphere. But the stable carbon of biochar is not going to decompose that way.
And how does it become bioavailable to plants and things if it's not able to be accessed by these natural processes? And how is it accessed by plants to make them more capable?
Well, it's impacting the soil structure, and then it's the pores that are holding, you know, the microbes and the nutrients and the things that is what the plants are going to be made available to the plants.
Sorry, I can add to that. There's
Yeah.
a really good paper that it's that the amount of carbon that's being picked off by the microbiome in the soil is so small relative to the size of the biochar. So it's like 3%, right? Or over time, it takes hundreds of years to actually like if this is your biochar, right, student, you're like every year, every year. And so it's so small, but it's so useful for the microbes around it, right? And so, and that's why it lasts so long. It's kind of like if you picture carbon, right? The strongest form of carbon is a diamond. It's like on that process. It's so hard, and it's so hard for other things to break it down that you're only breaking off little pieces of the surface every year, so that it's still relative to the size of the char. There's still a lot of it left in the soil.
So is it in some other chemical form?
Carbon.
Yeah, it's carbon, it's C6. It's on the, based on temperature, it's on the way of moving to graphene, right? So,
But it's bound to the other molecules in such a way that it's not going to connect oxygen or other things.
no, well, now you're really delving into
Yeah, okay.
functional groups and things on the hydrogen carbon. And that's where I was going with the hydrogen. When you get your lab test, you basically get what's called a hydrogen carbon ratio. That hydrogen carbon ratio is what defines the longevity of the carbon. So
Okay.
a lower temperature carbon is more labile to a degree, with being available to microbes to break it down as food,
Okay.
right? So if you're on the if you're at a higher spectrum on that ratio, then it's only gonna last maybe 100 or so years.
Mhm.
If you're on the higher end of that carbon to hydrogen ratio, then it's gonna last thousands of years, because that means you're more carbon than you are to it. So that's why, and that's what's calculated in your carbon footprint analysis.
Okay.
And I think the process of burning.
Well, it's not actually burning.
Some of it was burning. I mean, I've seen
Right.
Only,
solo stove before. That looks like a big old solo stove.
well,
But I
it's
thought that
still,
created
it's
massive-
rare it's actually cooking the carbon. I like to use the analogy of roasting coffee, right? You can have a venti roast, or you can have a espresso roast that's almost 98% carbon. If you didn't burn the bean away, right, you're roasting it. So it's the same concept as when you're down in the ring of fire or whatever, there's no oxygen in the bottom. It's only at the top that's being brought back through. You're essentially just cooking the vapors and oils, bars out of the feedstock. And all it's leaving is where all the vapors, water, tars that were in the pore spaces, and you're keeping the structural component of the feedstock as fixed carbon. So there is ash, because the only way you don't get ash is in a pyrolysis unit, which is zero oxygen. In some cases, they pump nitrogen in. But in a gasifier, there's a small fraction of oxygen. So there might be 2 or 3% oxygen in there. So that's more for the conversion of carbon dioxide. But you end up essentially retaining a fair portion of the fixed carbon with the ash, minimal ash.
So one thing you said that, well, you couldn't add it to the soil because it robs the soil, the nutrients.
It
So
would
maybe you
compete
had to
with
put
your
compost in
plants.
it?
It would compete with your plants for nutrients.
What
It's
does that
going,
mean?
I mean,
Initially.
yeah, it's going to draw in the nutrients. They're going to be like basically attracted to the charcoal, and the plants are not going to be able to compete.
So why does it draw in the nutrients from the soil? That's
Because
what-
it's like a sponge.
Sponge,
Yeah.
Think
it's
of it
like
as a biological battery. Yeah, it's a battery, a biological battery, where all light wants to be connected to the carbon and what's in that carbon, right? So it gets absorbed. So it'll absorb nitrogen and absorb all the nutrients until it gets balanced, and then it gives it back. So.
Yes.
I think we're
You
time
want
for
those
just
to
one
be-
more question.
Okay, one more question.
Thank you. I've been involved with a lot of discussions about road salts and ice melters, and there's been some research about how those chlorides and ice melters can really affect the soil structure and our stormwater bioretention practices. Would biochar help with that? Is biochar going to mitigate salt damage or absorb those chloride ions in the same way that it absorbs other things in those pore spaces? Do you know if there's been any research done on that, or is it?
I'm sure I'm glad Chuck is here because.
You can, what they call, designer chars, so you can modify the structure as it relates to the ionic or anionic activity of the carbon. But if you just take straight up biochar, no, it's the wrong charge.
It'll increase the porosity.
It'll increase the porosity of it for infiltration through. It'll keep your soils from getting, locked up, sort of compacted into, or what's the word I'm looking for? Almost like concrete, right, with it. So it'll keep that from happening, but it's not going to be a direct absorption.
Chuck, it would bind with the metals that would be liberated by the salt. Actually,
Do what?
it would bind with the metals.
The salt.
Well, the biochar.
With the metals, yeah.
Yeah, so
Yeah.
the chloride is gonna liberate the metal, but maybe it would, I don't know, I'm just talking theoretically.
Yeah, I haven't seen any research.
I want to thank you all for coming to this presentation.
Thank you again to our wonderful speaker. I love the 101 on biochem. Reminder how that was. So sorry to hand these out before. I'm handing them out now. Pass them down.
I had a question about the mix of biochar and compost. Do you do it by parts of like this amount of biochar?
I think I would probably like a 1 to 4, like biochar and compost.
Okay.
Not like half and half. You definitely don't need as much. of the biochar.
Yeah, basically, you were gardening, and I was like, we don't show the